Welcome to Lesson 53 in Hydraulics 102 and Lesson 2 in the section on hydraulic valves and control components. This lesson is going to be an introduction to the directional control valves. In the previous lesson, we touched on directional control valves for a bit, but in this lesson we are going to explore this component some more. Now, what are directional control valves? Directional control valves are control components or valves which regulate the direction of the work fluid flow. The abbreviation for them is DCV. DCVs, they can stop the fluid flow, they can allow the fluid flow, they can change the direction of fluid flow, and they can also regulate flow. Those are directional control valves which are analog, and we will explore them later. Before we continue, we have to talk a little bit about the notation or nomenclature used for DCVs. You will often see this format, number/number, when looking up directional control valves. Now, we have to know what this means if we want to continue learning about these types of valves. Now, the first number indicates the number of ports the DCV has. For example, if you look at this DCV right here, this is a schematic symbol. It's much easier to see. We can see that it has 4 ports. It has the work ports that go to the work elements A and B. It has the pressurized fluid line, and it has the tank or the return line. So this is 1, 2, 3, 4. Okay, so first number is the number of ports. So this valve is 4/. Now let's see what the second number is. The second number indicates the number of positions our valve can take. For example, here we have these 3 different squares, 3 different positions, and in the square number 1, the pressurized fluid will flow from the pressurized line to the B working line, and the A working line is going to go to the tank. If we put it in the middle position, we are not going to have a connection, and if we put it in the third position, the pressurized line is going to work elements A, and from B we have the return line. So this valve has 3 positions, 1, 2, 3, making this valve a 4/3 directional control valve. So these are the 3 positions, indicating that this directional control valve has 3 possible positions. It is pretty easy and intuitive. Just remember, first you have the number of ports, and then you have the number of positions. Now let's look at these 4 examples right here. So this is a 4/2 valve. We have 4 ports, 1, 2, 3, 4, and we have 2 positions, making this a 4/2 valve. 5/2 valve, we have 5 ports, so we have 1, 2, 3, 4, 5, and we have 2 positions, making this a 5/2 valve. Now 4/3 valve, we already saw this kind of valve, but this is kind of a mirrored valve. If you look at these 2, it has 4 ports and 3 positions, and the 5/3 has 5 ports and 3 positions. Center is closed, meaning there are no connections between the working elements and the pressurized and return lines. Now let's do a little exercise together. I put little squares that will move and reveal how we note these directional control valves. But first, we'll count it together, okay? So this DCV right here, we have the symbol. So let's see the number of ports. Here we have 1, 2. We have 2 ports and 2 positions. So we write 2 ports / 2 positions. So 2 closed ports in the closed neutral position and flow during the actuated position, a 2/2-way valve. Okay, here the second one. We have 1, 2, 3. We have 3 ports. So we write 3, and we have 2 positions. So we write /2. So in the first position, flow takes place to the cylinder, And in the second position, flow takes place out of the cylinder to the exhaust, meaning to the tank. And this is, for example, for a single acting hydraulic cylinder. Now here we have 1, 2, 3, 4. We have 4 ports, so 4 slash, again, we have 2 positions, 4/2. So this is for double acting cylinders. All ports are open, meaning we don't have the middle closed position like we have in these kinds of valves. So here we have, again, we have 4 ports, so 4 ports slash 3 positions. Now we have 3 positions, so 4/3. 2 open positions and 1 closed neutral position. So this is the closed neutral position. And the last one we have, as we can see, 1, 2, 3, 4, 5. We have 5 ports, and we actually here we have 2 positions. So 5/2. 2 open positions with 2 exhaust ports. Okay, so we know how to name them, but we also have to see their basic parts and how they function. We can't rely only on the schematic symbols, right? So here we have a spool directional control valve. On number 1, we have the spool, which is located all along this housing that we have on number 2. On 3, we have the closing bodies, which are used to seal or to close these little ports that we'll see how it functions in a minute. On 4, we have the spool seatings, so this is a spool seating, and this. And on number 5, we have the spring, which brings the spool back to the 0 position. So this valve has 2 positions. Now there are some standards in marking things when it comes to directional control valves and schematics. So we usually use A, B, C, D for lines that go to the working elements, hydraulic motors and actuators, for example. We use P for pressurized lines, and we use R, S, or sometimes T for return lines. Now for pilot lines, which bring the fluid which actuates the directional control valve, we use Z, X, and Y. As you can see from this picture from the previous lesson, X1 and X2 are the pilot lines which actuate this directional control valve. Now this valve has a combined actuation. Remember, it has pilot lines for the work fluid to activate it, and it also has these springs which bring this DCV in its neutral position. So the lines are marked with X. Let's see the directional control valve in operation. Now this is the valve in position number 1. In other words, someone is holding this lever and pushing it by hand. By doing so, he or she is closing the ports between A and the return line. So here fluid can't flow. We can't have fluid flow. And also, we can't have fluid flow from B to here. So this is also a no-go. So here we don't have fluid flow in this position. However, closing this allows the pressurized fluid from P to go to port A and from B to go to the return line. Okay, so in this position, pressurized fluid goes to A, and we have a path of fluid from B to the return line. Now, because this DCV has a spring inside, and when the person which is holding this lever releases the lever, the spring pushes the spool with the parts that close and obstruct fluid flow back, as we can see right here. So what happens right now? The spring returned the spool in its neutral position, so we have pressurized fluid flow going to the working elements B, and we have the return line connected to port A. Now, question. If we wanted to name this valve, what name would we give it? Maybe valve the spool DCV, but I'm actually talking about the notation, about the two numbers. So if we count these ports, we can see 1, 2, 3, 4, 5. Okay. We have 5 ports. So 2 ports going to the work elements, 2 return ports, and 1 pressurized port. So this has 5 ports and it has 2 positions, 1 or 0, okay? So it is a 5/2 DCV. That is the name of the valve. Well, wrong. This is represented in a way that indeed it looks like these are 2 different ports. But remember, lines that have the same path bring the fluid to the tank in this example. So this R and S actually are going to the same line. They actually have the same path. Now this picture right here, this cutaway diagram, this is represented in a way that indeed it looks like these are 2 different ports. But remember, lines that have the same path bring the fluid to the tank in this example, so R and S, are counted as one line. So this is not a 5/2 valve, this is actually a 4/2 valve. Now if we take a look at this example right here, this animation, we can see that this block, this DCV, has 2 return lines, right? But it actually comes to 1 port. So this is a 4/2 valve. It has 1, 2, 3, 4 ports. So you can clearly see that even though this one has these 2 lines, so we have here the 2 lines, they eventually go out the block together to one specific line. Remember, lines that have the same path bring the fluid to the tank in this example are counted as one line. This again brings us back to the example with the cylinder direction. In the first position, we have the pressurized fluid going from pressurized line to B, filling the back of the piston, pushing it to the left side. We have the return line to A, so we have the fluid going back to the tank. If we change the position of the spool and close up the fluid pathways, we have the pressurized fluid right now going to the front of the piston, pushing it to the right side, and we have the return line connected to B, going back to the tank. There are a lot of ways of classifying directional control valves. One of the ways would be to classify them on the type of motion that is happening to direct the flow of the fluid. And we can classify them into 2 groups. We can classify them in rotary directional control valves, which have a rotational element that directs the fluid flow inside of them, and we have linear or translational or sliding motion directional control valves that we already looked at in the previous slides. Now, rotary directional control valves. These kinds of directional control valves have a rotational, cylindrical, or conical piston as the active element. So right here in the center, we have a piston that has pathways for the fluid. And as we rotate it, we change the direction of the fluid. So here we can see a little example. So if we put this valve in the first position, we have the connection between the pressurized line and B, and we have the port A going to the tank. We have the neutral middle position, which is the closed position, and we have the third position. Now, the ones that are used more often are the ones that have cylindrical pistons because they are much easier to manufacture, and for their actuation a small force is needed, so they can be activated by hand. As you can see from this picture right here, the ports are positioned radially around the DCV. So, translational motion directional control valves. these are the most used types of directional control valves if you compare the rotational ones and the translational ones. They have good sealing properties and they have compact constructions. Although they don't actually have any sealing elements, the sealing is done by labyrinth sealing. They are simple to actuate, you just have to push them left or right, and this is why they are the most used directional control valves. We can also classify directional control valves by the type of signal they output. When we say signal, we mean the signal of fluid flow. We can group them into discrete or digital DCVs and analog DCVs. Discrete signals of flow are either flow is on or flow is off. There are no in-between positions. When it comes to analog directional control valves, they don't only regulate the direction of the flow, but they can also regulate the quantity of the fluid flow, making them analog, so to say. So discrete DCVs have only two values, as we saw from the first examples. Either we have flow in the direction or we don't have the flow in the direction, and they don't have intermediate or in-between positions. They are either at one position, DCV position of course, or at the other. Although they have two states, either 1 or 0, this shouldn't be confused with the positions in which the DCV can be. So this DCV is discrete, but it actually has 3 positions. Discrete meaning there is flow or there isn't flow through the port. Analog DCVs are different than discrete ones in the sense that they can have in-between positions, and therefore they can regulate the amount of fluid flow as well as the direction. This is a symbol which you can recognize, but it has this parallel line beneath and above, which tells us that this valve is kind of on a rail and can occupy in between positions regulating the flow. There are two types of analog directional control valves. There are proportional DCVs and servo DCVs. We will cover both in 2 separate lessons. And this is it for directional control valves intro lesson. Thank you for listening and for staying focused. See you in the next lesson, in which we will talk a little bit about sectional and monoblock control valves.